Okay, so we're going to do 11.10. So this is a very important question that is going to show you that whenever the marginal cost is higher than the average cost, then the average cost is going to be increasing, and whenever the marginal cost is smaller than the average cost, then the average cost is going to be decreasing. Okay. We are given an average cost function ACX, where X is the total number of output. It's going to be equal to the total cost function divided by the total number of output. Okay, so it's asking you to find the derivative function dAc of X, differential with respect to X. Okay, so I know this is the function of the average cost. So if I differentiate this with respect to X, now basically we are using the quotient rule over here, where we have two functions of X, the one on the numerator and one is on denominator. Okay, so using the quotient rule, then you are going to get C dash of X times X minus Cx times differential of X with respect to X, which is 1, and everything divided by X squared. Okay, so applying the quotient rule, we are going to be able to get this. Now, so given that C dash of X is just going to be the differential of the total cost function with respect to X, and we know that that is equal to the marginal cost function. Okay, so therefore if we substitute that into here, then I got dAcx on dx equal to marginal cost of X times X divided by X squared minus Cx divided by X squared. Okay, now so X divided by X squared will just give me X, so I got marginal cost of X divided by X, and over here I got Cx on X squared. Now Cx on X squared is just basically Cx on X, everything divided by X, and we know that Cx on X again is just the average cost function over here, so that is going to give me marginal cost of X on X minus average cost of X on X. Okay, so that is marginal cost of X minus the average cost of X, and everything divided by X. Okay, so this is what the question asking you to prove. So as you can see, if the marginal cost of X is greater than the average cost of X, then the whole ratio over here is going to be positive. Okay, and so therefore dAc of X on dx is going to be positive. Now this positive means that whenever X is increasing, the average cost is going to be increasing. Okay, so average cost is an increasing function of X. Okay, increasing in X, so whenever X is higher, average cost is higher. Okay, however, if the marginal cost of X is smaller than the average cost of X, then we know that this ratio over here is going to be smaller than 0, so then the differential of the average cost function with respect to X is going to be smaller than 0, which implies that whenever X is higher, average cost is going to be lower, and vice versa. Okay, so that is the case where average cost is a decreasing function of X, or decreasing in X. Okay, so what does that mean in terms of a diagram? Okay, so if I got a very quick diagram over here, where I got just the average cost and the marginal cost on top, and over here I have X, which is the total level of output. Okay. Alright, so in terms of a diagram, it's going to be meaning that, so if I got an average cost function like this, and if I got a marginal cost function like this, okay, then whenever marginal cost is above the average cost, so as you can see, this is the intersection point, and to the right of this point, the marginal cost curve is higher than the average cost curve. Okay, now as you can see, if that's the case, then the average cost is increasing in X. So as you can see, this average cost part over here is increasing in X. Okay, so as you can see, it is an increasing function, so it's going up. Okay, now to the left of this point, where the marginal cost, which is this curve over here, is below the average cost, then we know that the average cost is going to be decreasing. And as you can see, the average cost function is decreasing. Okay, so it's decreasing and then increasing, and this is the minimum point of the average cost. Okay, so one very important property you will have to remember when you draw a diagram is that marginal cost is always cutting through the average cost at the minimum point of the average cost. Okay, so note, marginal cost is always gonna cut through the average cost, okay, at the minimum point of the average cost. Okay, so the idea is that whenever the marginal cost is lower than the average cost, which is to the left of the minimum point, then the average cost is decreasing. Okay, and after this point, marginal cost is going to be increasing, and so therefore this is the minimum point on the average cost, and that is the intersection between average cost and the marginal cost.